All right, so for the noun calculator part, it's important that we can sketch our like graphs. So I'm just gonna do some parent functions. So quadratic, the y equals x squared. Hopefully we all know looks like this. And if it's negative x squared, right, it's gonna look like this. Or I guess that's shifted down like that. All right, cubic will look like this. Square root starts at 0, goes up like that. Natural log, similar, but it goes down into the negatives and flat. E to the x will look like exponential. Cubic root looks like square root, but then negatives. And 1 over x looks like this. Alright, using dx or dy, and do you need a pi or not? Cross section is perpendicular to the x-axis, that is a dx. You do not need a pi to make, well, depends. I guess if it's squares or rectangles, right, you don't need a pi. If you're looking at semicircles, you wouldn't need a pi. Solid made of cross sections perpendicular to y, dy. Solid made revolving around the x-axis, dx. Revolving around the y-axis, dy. Revolving around the line x equals 2. X equals 2 looks like this. That is going around a vertical line, similar to going around the y-axis. That is in dy. If I go around the y equals 2 line, that is a horizontal line, very similar to going around the x-axis. That's going to be dx. Here, we're allowed to use our calculator. So first, I want to know the area of the regions bounded by those two graphs. So I'm going to 2x cubed minus x squared minus 14x. This one is 4x minus x squared. Graph them. Oh, that's weird. Okay, so I can't really see all the intersections, so I'm going to go to window, and I'm going to go like maybe from negative 20 to 20 for the y. I think that's enough. I used that earlier with somebody. Alright, so it looks like it's intersecting here and here and here. So I have 3 intersections. I'm going to sketch my graph. I've got my cubic looking like this. That's this one. And then my other one goes through 0 like this. That's this guy. So I have this area and I have this area. I have 2 different regions. So I could take the time, right, do second, intersect, find the, well, that's easy though, 0. Second intersect, find the other intersections. But this is multiple choice. It kind of gave me that was negative 3 and 3. So I'm going to have 2 setups. I'm going to have negative 3 to 0. And I'm also going to go from 0 to positive 3. In this setup, you'll notice that the function on top is the cubic function. So I'll have the top function, the cubic, minus the bottom function, the 4x plus, or 4x minus x squared. Now it looks like I need to simplify this, so this will become minus 4x plus x squared. Minus x squareds will go away, that'll become minus 18x. This is 2x cubed minus 18x. From 0 to 2, what's different is on top is the quadratic, so it'll be 4x minus x squared minus the cubic function. And then you guys can simplify this. You're going to end up getting negative 2x cubed plus 18x here. So then the one that matches is C. D would be flipped both sides, and then you would get a negative area for both. All right, number 2. Solids generated around, the solid is generated when the region in the first quadrant enclosed by this graph, which looks like this. The line x equals 4, the x-axis, and the y-axis. So this is all just describing what's enclosing the area. So x-axis, y-axis, the graph, and x equals 4 line. So when this area is revolved about the x-axis, so this is a revolving around an axis, it's around the x-axis, so I want it to be in dx. I'm going from 0 to 4, because that was the x values, right, y-axis, and the line x equals 4. This is going to be a pi r squared. It's not going to be a pi r squared minus r squared because see how it's actually like solid all the way through, right? We're not going to have like gaps. And my radius at any point will just be the height of this function, which is this right here. So I'm going to do pi r squared dx, right? My r is this right here. Now there's a squared, but that isn't the r squared, right? That's just what the radius is. Now I need to square what that function is, so that is why it is the e, right? I'm raising it to the 4th power because the function got squared, so now it's to the 4th. Base of the solid in the region enclosed by those two curves, so square root of 2x and negative square root of 2x, but I only want it from 1 to 2, so this right here. And I want the cross sections to be perpendicular to the x-axis, so that's going to be dx. And I want them to be squares, so I'm going to take this and square it. I'm going to do, so they're creating squares like this, so the base of the square is just the top function minus the bottom function, so square root of 2x minus negative square root of 2x. And I'm going from 1 to 2 because it gave me the interval. So then now we just go to our calculator, math 9, whoa. Math 9, 1 to 2, square root of 2x minus negative square root of 2x, x. Oh, I didn't square it. I was like, oh my god. Forgot to square. Oh, there we go. So you should get 12. Which represents the area of the regions bounded by the curve this and this. So we're going to do y equals 4, and I can actually do this in my calculator. You don't need to do it in your calculator because hopefully you know it, but why not? So it looks like this. I need to know my intersections, right? Like what these two are. So intersect, I get negative 1, and my second intersection, go over here, is x equals 2. So I'm going to go in the x direction, negative 1 to 2 dx. Top minus bottom is the negative x squared plus x plus 6 minus 4. And then this will become negative x squared plus x, 6 minus 4 is plus 2. So negative 1 to 2, okay. So I'm looking at the graph of y equals 0, which is this. Y 1 over x squared, which looks something like this. X equals 1, and then x equals c, which is between 0 and 1, so somewhere in here. So this is c, this is 1, this is my function, and then I'm bounded in, so make these four like the walls of this area. This area is revolved around the x-axis, and we're talking about the volume formed is 2, so let's get an equation for the volume formed. Well, we would be doing pi r squared, so pi r squared, the r would just be the function value, so pi 1 over x squared squared dx, and I would be going from c to 1. So this is just the same as pi c to 1 of 1 over x to the 4th dx. This is my volume. I want my volume to be 2, because it said my volume is 2, and now I'm solving for c. So I'm going to actually take the antiderivative. This is just the same as x to the negative 4th. If I take the antiderivative, that would be x to the negative 3 with the negative 1/3 out front. So this is the same as pi negative 1/3 x to the negative 3 from c to 1. So that's the same as pi times negative 1/3 1 over 1 to the negative 1 minus 1 over c to the negative 3 equals 2. So I'm going to divide the pi over. I'm going to multiply by negative 3. And then, so I've got 2 divided by pi times negative 3. So that's like a negative 1.909 right now, equals 1, oh, that's just 1. 1 minus 1 over x, this right here. So I'm going to subtract the 1 over. That gives me negative 2.909 is negative 1 over c cubed. I guess I don't need the negative 3 if I'm putting it on the bottom. My bad guess. And then the negatives cross off. Now I'm going to multiply the c cubed up, divide this over, so 1 over that number is 0.343 equals c cubed. And then to get rid of the cubed, I'm going to cube root, so that's math 4 of the number, and that gave me 0.7. So once we get to here, right, that's just algebra. Number 6, so, I shouldn't have written on this. Anyway, f is the function, this right here, 4x squared minus x cubed. L is the line tangent to the graph at x equals 3. I first want to find the equation of the line. So for equation of a tangent line, right, you need a point and you need a slope. Point. So my point, I know x is 3, so I'm going to say 3. And then let's plug in 4 times 3 squared minus 3 cubed. The point is 3, 9. So this point right here is 3, 9. Now to find the slope, well, the slope is just going to be f prime of 3. So f prime of 3. You can take the derivative by hand. That's super easy. If you don't want to, you can do the derivative in your calculator. So math derivative, it's math 8, d dx of, what is it, 4x minus x cubed? Yeah. 4x squared minus x cubed evaluated at x is 3. You get your derivative is negative 3. So then y minus y1 equals mx minus x1. Y minus y1 is 9 equals slope negative 3, x minus positive 3. So that's the equation of the line L. Now I want to find the area of R. So if we're looking at the area of R, it actually has nothing to do with the tangent line at all, right? It's just the area of the graph. So this is going to be the integral of just f of x from 0. And now I need to figure out when this hits the x-axis. So you have a calculator. So what we can do is two ways to do it. You can do 4x squared minus x cubed. And you can say 0 to see where they intersect. It intersects. I don't want the first one, I already know it's 0. And then this gives me x equals 4, so I know that it intersects not just 0, but also this is 4 right here. The other way to do it is if you didn't have the 0, you could just graph the function. And similar to doing the intersect, you can go to 0, and it'll find the 0 for you. But then it's kind of finicky the way it moves around, so I prefer to do the 0 intersect, but it doesn't matter. So the area would just be 0 to 4 of f of x dx. So then we take our antiderivative, 0 to 4 of f of x, and we get 21.333. All right, area of S. So area of S is a lot more complicated, so let me just kind of sketch it right here. We know this point right here is 4. We know this point right here is 3. And then I need to know this value, so I'm going to take my equation of my line. I'm going to rearrange it. So this is negative 3x minus 3 plus 9. Right, just rearrange, which is the same as negative 3x plus 9, which is negative 3x plus 18. So that's this line right here. I want to know when it crosses the x-axis. So you can put it in your calculator, or you could just set this equal to 0. It's pretty easy. So 3x equals 18, so x equals 6. So this is 6 right here. Now the tempting part here would just be like the line minus the function from 3 to 6. But that actually would only give me the area between them right here, right? Because this area right here is not the area between the line and the function, because the function's doing some like way down here stuff. That's not what I want. So I'm actually only going to do the integral between them from 3 to 4, because that's the only time that it's like top minus bottom. So I'm going to do the integral from 3 to 4 of the top function, which is the line, the negative 3x plus 18, minus the bottom function, which is the 4x squared minus x cubed. 3 to 4. Make sure you put your parentheses around these. Some of you are missing points on exit tickets for that. So this right here is 1.9967. Now that is not all of area S, because all of area S, right, is all of it. So I just found this right here, so make a note that is 1.9167. Now the rest of the S is this triangle right here. So I already know the base of the triangle is 2, so I'm going to say base times height over 2. The base is 2. I just need to know the height. So the height is just what the line is when x is 4. So I'm going to plug in y equals -3 times 4 plus 18. -12 plus 18 is 6. So then see how the height right there is 6. So all I'm doing is I'm saying, okay, I actually don't need an integral right here. You could do just the integral. Actually, that would probably be easier. I don't know why I did this as a triangle. I'll show you the other way. So plus the integral of just the line, which is -3x plus 18 from 4 to 6. Yeah, that's easier. I don't know why I was doing my... Well, I guess it's not easier. It's the same amount of work. But if you have a calculator, some of you probably prefer to just type in. Alright, so when I take my antiderivative, I got that this was 6. So I'm going to add these two together. This area plus this area will give me all of area S. So then area S of S is 7.9167. Okay. dr is the base of a solid for this solid, each cross-section perpendicular to the x-axis. So dx is a square, so I'm going to have something squared. I should not have a pi here. I'm doing it in terms of x. We're talking about region R, so I'm going to go 0 to 4. These perpendiculars, so these squares that are created by perpendicular lines to the x-axis, and any given x value, then the base or the length of the square, or the side of the square, is just going to be the function value f of x. So this is just f of x. And here it just says write the expression that would compute. It doesn't say to find it, so I'm just going to leave it like that. Region R is the base of a solid. Here we're talking about a semicircle. So semicircle is pi r squared over 2. So I'm going to have pi over 2 out front. I'm going to have some radius squared. It's still perpendicular to the x, so I'm still going to have it dx, 0 to 4. Here, so if these were making semicircles, the function value would actually be my diameter. So I want to take the function value divided by 2. So this is just f of x divided by 2. But the 2 is getting squared, because that's part of the r, right? Half that is the r. Region R models the surface of a small pond at all points in R at the x distance at the distance x from the y-axis. The depth of the water is given by this, right? An integral that would compute the volume of the solid. So what this is saying is, okay, if this is my pool right here, then the depth of it would be this right here. So to get the volume, you would just do area times the depth, right? We're breaking it up into little cross sections perpendicular to the x-axis like this. So I'm going to do this distance right here, which is just f of x, times the depth, 3 minus x, and that's just one of them. So do dx, integral it up from 0 to 4. That's not the correct way of saying it. And that is your area. Here we've got R and S are the regions in the first quadrant. This is tangent. This is 2 minus x cubed. S is bounded by the y-axis and blah, blah, blah. Find the area of R. So area of R is a little bit tricky because what people are tempted to do is top minus bottom. I don't have a top minus bottom. What you could do is right minus left. So I'm going to put this in terms of x. Subtract over. That would be 2 minus y, and then you'd need to cube root it to get to x. And then here, undoing tangent is just x equals tan inverse of y. Okay, so now I have it in terms of y's, right? So I would do right minus left. So right would be this one. So cube root of 2 minus y minus the leftward function is the tan inverse of y dy. And then because we're doing it in terms of y, I need to find like this y value. So I'm going to do 0, 2. I need to find what it is. So I'm going to type in the original functions, the tangent x and the cube root of 2 minus y. Oh, sorry. This is silly. I'm doing it in x, 2 minus x cubed. So I'm just graphing it right now. Trying to find those intersections. So this intersection, I'm going to make an arrow down here, is 0.902155 and 1.2657. Right, I'm doing in the y values right now, so I want to go to 0 to this y value, 1.26575. Right, and then now I can just put this in my calculator. Technically these are y's, right, but the calculator, I mean if you want to type a y instead of an x in, that's totally fine. It just takes time to find the y on the keyboard, so I just left it as the cube root of 2 minus x dx minus, oh, why did I do that? I want you in there. Minus tan inverse of x. There we go. So I get 0.729 as my area. The other way you can do this, if you don't want to put it in terms of x, so you could just say, oh, if I break it up right here, see how that's just the integral under tangent, and then from here it's the integral under that. So you could do the integral of tangent plus the integral of this, and this one's from 0 to the 0.902, and this one is from the 0.902 to this intersection, which I haven't found yet, so I'd have to find that. So let's set, that's where tangent equals 0. So I graph tangent and 0, so I'm just going to find where this intersects. And I already know that one, so this. So this is 3.1, oh, pi. That makes sense. Anyway, this one is 3.14159 right here. So then you would have to do it 3.14159. And here we break them up, right? I'm not doing top minus bottom. I'm not doing this one minus this one or vice versa because one is not on top of the other. If I'm doing right minus left, it has to be in terms of y, which is what I did up there. But let me just show you that you get the same answer. So 0 to 0.092. We should have put more decimals, but I already put that, so it's okay. Plus, and now these are separate integrals, right? Because I'm actually changing the bounds. Now I want to go from 0.902 to 3.14159 and 2 minus x cubed dx. Oh no, I should be getting the exact same answer. I must have messed this up. Oh, I did not want where tangent equaled. That was my bad. Sorry, this is when this one equals. I did it earlier. This is actually 1.2599. Woo, guys, careful. I picked the next tangent, but that's not what this one was. This was the cubic. My bad. Okay, so that actually should have been 1.2599. So let me show you that it is the same. Just replace the 1.2599. Yeah, so when I fix that number, it actually gave me back. Alright, region R is rotated about the y-axis, so I need to have it in terms of dy. So I need to have from 0 to this y point, which we already said the y value was the 1.26575. And then we want to do pi r squared minus pi r squared, right? We're doing the washers outside function minus inside function. So my outside function is the cubic, but I need it in terms of y, so it's going to be cube root of 2 minus y squared minus inside function, which we decided was tan inverse y squared with the pi. So pi outside squared minus inside squared dy. The region R models the surface of a pond. At all points in R, the distance y from the x-axis, the depth of the water is given by this. Compute the volume. So now we're doing it like in terms of y, so it would just be the width, right, would be this distance right here, which is the cube root of 2 minus y, minus this one, which is tan inverse of y, times the depth, 2y minus 1. And we're not doing like revolving or making circles, so I don't need a pi here. And I need to put my bounds in terms of y, which is 0 to 1.26575. Alright, region in the first quadrant bounded by the graph of secant, 1 over, this is just 1 over cosine, x equals pi over 4, and the axes. What does secant look like? Secant is 1 over cosine, so starts at 1. And goes up. Okay, whatever. So I'm taking this area and I'm rotating it about the x-axis. So this is going to be a pi r squared equation. Pi r squared where the radius is just secant. So this is pi secant squared x. We're going from the axes, so from 0 to pi over 4. Alright, and then now you can just evaluate. So I want the actual amount. So pi, math 9, 0 to pi over 4. I want 1 over cosine squared. Yes. And that gives me just pi. I guess I could have left the pi out, and then you would have your answer in terms of pi. Alright, now we're in the no calculator. Area enclosed, so y equals x looks like this. Square root looks like this. This is square root of x. This is y equals x. So they intersect. Hopefully you know at 1. You can set them equal, but it's going to be at 1 and 0. I don't know why I did that. 0. So I'm going to do this area from 0 to 1, top minus bottom, so root x minus x dx. This is just x to 1/2, so the anti would be 3/2 with the 2/3 up front, minus 1/2 x squared, evaluated at 0 and 1. So that's 2/3 times 1, minus 1/2 times 1, minus 0. That's just 4/6 minus 3/6, which is just 1/6. That's your answer. A solid is generated by revolving the region bounded by x squared and square root of x between 0 and 1 around the y-axis. I can put this as x equals y squared and x equals square root of y. This one is the square root of x, which is the y squared equation. And this one is the x squared, which is the root y equation. So when I go around the y-axis, I want pi outside radius, which is y squared, minus inside radius, which is square root of y squared dy. And I want it, this one is 0 and 1, and then the y I think is also, yeah, when you plug in 1, you get a y value of 1, so it's still 0 to 1. This would become y to the 4th minus y, so pi 0 to 1, y to the 4th minus y. 2 is F. The base of a solid is in the region in the first quadrant by, this is 4 minus 2x, looks something like this. We are not using calculators, and the coordinate axes, so this area right here. Cross-section perpendicular to the x is a square, so I want it in terms of dx. I want squared, no pi, sub A, and the height or the width of the square or whatever, the side of the square at any point is just 4 minus 2x. So it's 4 minus 2x squared dx, and we're going from, I need to know what I'm going from. So this is 0, because I'm starting on the axes, right? I need to know where it hits, so 4 minus 2x equals 0, that's 4 equals 2x, so x equals 2. So from 0 to 2, so it's B. Alright, solid is generated by revolving y equals to e to the 2x, y equals 1, x equals 2, so x equals 2 would be like e to the 4th, which is like way over here. This is x equals 2, y equals 1 is like something like this. So I want this area right here revolved around a line down here. So this is going to for sure be a pi r squared minus pi r squared equation. Pull the pi out front. The big R, right, if you're going down around like this, your outside radius is the e to the, we know it's dx, by the way, because y equals -3 is a horizontal line. So it looks similar to going around the x-axis. So it should be dx. My outside function, or outside radius, is this function, but I have to measure it relative to y, so it's going to be e to the 2x. Subtract that, which will become plus 3 squared, minus this one, which is 1, subtracting the negative 3. So that will just become minus 4 squared. E to 2x plus 3 squared minus 4 squared. Ooh. So B. S is the region bounded by y equals negative x, and this is, well, let's set them equal because I don't know exactly where they intersect. So let's set them equal. Negative x plus x over log of 2x. This is x minus 2, so they intersect at 0 and 2. So here and here, so it must look something like this, I guess. Alright, and we want to rotate it around the line y equals 5, so that's going up this way. So the squared equation is your outside. I need to measure it relative to 5, so you could do 5 minus the 2x squared minus 5x squared minus 5 minus negative x squared pi blah blah blah. I apparently did it this minus 5 squared. It's the same thing, right? It doesn't matter if you're getting squared, which one is in front. The order of the squared minus the squared matters because that's not getting squared. So I should have the quadratic one in front and this one behind. It should be going from 0 to 2, which is the two things we found. I should have a pi, and there should be this one minus this one, so C. D is super similar, but because you have it out of order, you would just get a negative volume. Alright, finding the volume of the solid generated by revolving the region bounded by y equals x cubed. Y equals 8 is like 2, right? In the y-axis, so here, so I'm doing the region between these three functions around the y-axis. So this is just a pi r squared equation because there's not going to be like an inside to cut out, right? So this is pi. The radius at any point is the x, which is x equals cube root of y. Cube root of y squared dy. And I want to go from 0 to 2 cubed is 8, so I want to go from 0 to 8. This is y to the 2/3. So I need to take the antiderivative. That would be y to the 5/3 with the 3/5 out front, evaluated at 0 and 8. Ooh. Pi 3/5, 8 to the 5/3. Third means to cube root it, so that's 2 to the 5th. 2 to the 5th is 32, so this is pi times 3/5 times 32. 3 times 32 is 96 over 5 pi, so A. Base of a solid in the region bounded by cosine and pi over 2. I think it's that, yeah.